So it'd be a problem similar to this one right here. And when we talk about vertical asymptotes, we're talking about when we're getting to these walls. Right? I referred to them as walls. The equations are always going to be x equals some number, whatever that number is. The way we find it is if we have a function f of x, we need the bottom to equal 0 and the top to not equal 0 for some x value. So we want to kind of look at when does the bottom equal 0, but the top not equal to 0? Well, the easiest way to do that is to kind of figure out when the bottom equals 0 and then just plug it into the top and see if it works. So let me show you what I mean. So let's take this example right here. We'll do a couple of examples, but let's take this one right here. We have f of x is equal to x squared minus 49, and we have 2x plus 14. Now let's take a look at this and we say, okay, well let's make the bottom equal to 0. For the bottom to equal 0, we need 2x plus 14 to equal 0. Well, that means 2x has to equal negative 14. That means x has to be negative 7. But now we got to check. We got to check x equals negative 7 in the top. And notice when you do negative 7 squared minus 49, you get 0. Well, that's not what we needed. For this value, when x equals negative 7, we get 0 on the top and 0 on the bottom. That is not a vertical asymptote. We need x. We need the value to be 0 on both the top and the bottom. So on this one, there are no vertical asymptotes, and that's because the vertical asymptotes, the denominator does not equal 0. So let's look at a different one. Let's take a look at this one. So on this one, I have f of x is equal to 5x plus 2 on the top, 3x plus 24 on the bottom. So if we look at this, we have the bottom equals 0 when 3x plus 24 is equal to 0. Well, that's when 3x is equal to negative 24. So that's when x is equal to negative 8. Now we just need to check. We need to check that on the top. We need to check that 5 times negative 8 plus 2 does not equal 0, and it doesn't because that's negative 40 plus 2, which is equal to negative 38. That's not equal to 0, so we're okay. So x equals negative 8 is a vertical asymptote. So if we go over here, there is one vertical asymptote. It is x equals negative 8. If we submit that, they tell us it's right. So let me find another problem. Let's take something like I'm going to find one that I want to do. Let's take something like this one. This is perfect. So if we take this one and I write it out, and I write out So I got f of x is equal to 3x squared minus 14x plus 16. And I got 2x minus 10x plus 12. And so I take this one, and I got to figure out what the heck's going on with the bottom. And I got to figure out when 2x minus 10x plus 12 is equal to 0. One of the things I can do is 2x squared. One of the things I can do is I can factor out a 2. And I have x squared minus 5x plus 6 equals 0. So if I do a little more digging on this, I get x minus 3 times x minus 2 if I factor it. That means x minus 3 can equal 0, or x minus 2 can equal 0. So that means x is equal to 3, or x is equal to 2. These are the ones I have to check. I just have to check those in the numerator. So if I go back up here, I need to check. Does 3 times 3 squared minus 14 times 3 plus 16, does that equal to 0? Well, if I go through that, I'm going to find that this is 3 times 9 minus 14 times 3 is 42 plus 16. So we have 27 minus 42 plus 16. If we do the arithmetic on that, we will find that we would get, let's see if we do 27 minus 42 plus 16, we get 1. So that's good. That means x equals 3 is a vertical asymptote. But now we got to check 2. So we got to check 2 with the numerator. Still the same numerator. But we're going to plug in 2. So 3 times 2 squared minus 14 times 2 plus 16. We're going to check, see what that works out to be. So this is 3 times 4 minus 14 times 2 is 28 plus 16. So we have 12 minus 28 plus 16. Uh-oh, we get 0. This is bad. That means x equals 2 is not a vertical asymptote. We only have 3. So go back over here. There's one vertical asymptote, and it is x equals 3. Submit that answer. That's what we get, and it goes through and it kind of talks about it. And it actually factors the numerator and the denominator and then moves on. So hopefully that makes sense. Good luck. Let me know if you have any questions.